Hi and welcome back. It's Mrs. Hanks again. You guys should already have watched the types of maps video. So today we are going to go back over that a little bit, but we're also going to work on just overall our introduction to maps. Have your notebooks ready, be out taking notes. You guys will have a short quiz once you have finished this video. So again, remember, head your notes up, 1.1 Introduction to Maps. So to get started, I want you to take a minute to answer these questions in your notebooks. First off, what do maps show us? Secondly, what kinds of information can we see on maps? And third, how do we use maps? So take a minute, pause the video right here, and answer those three questions. So our objective today is to identify types of maps, the types of information presented in maps, and different kinds of spatial patterns and relationships portrayed in maps. So that's 1.1.1, 1.1.2, and 1.1.3. You guys don't necessarily need to write down the little pieces, but definitely write down that first learning objective. So because we already went over this in another video, I'm just going to hop through it really quickly. You don't necessarily need to take these notes again, but you certainly can if you want to. First up, we have the types of maps. We have reference maps. This is giving us our general information. We use it for navigation and for location. And we have three major types: political, physical, and road maps. Make sure too that you're looking at the pictures when I show them to you. Second up, we have thematic maps. These are used to communicate information about a place. So spatial aspects, what's it like there? And we have several types of thematic maps. We have choropleth, dot density, graduated or proportional symbol maps. Those are the same thing. It can either say graduated or proportional symbol. Cartograms and isoline/topographical maps. So choropleth, remember that's our different colors. So here choropleth, and think color, choro color. Next up, we have dot density maps, and each map represents a specified quantity of a specific characteristic. So the closer we see those dots together, it's a dot density map, the more dense that characteristic is in an area. Then we have the graduated or proportional symbol maps. The bigger that symbol, the more frequently that characteristic occurs in an area. And we can see here we're looking at largest foreign-born groups in each country, and it's going to vary a whole lot by where you are. Then we have cartograms. This is showing us a specific variable, but the size of the map is related to that variable. So it can give us some really funky looking maps. And here we're looking at two different maps of Africa. One would be our standard type of map that we look at, and the second would be our cartogram. That first one, standard, is the word I was looking for political. And the second is our cartogram, so we can see that the states or countries, states and countries are the same thing, are different sizes based on the population. So again, another cartogram showing the world population. We can see some countries are tiny, tiny. India is disproportionately huge. China is huge. Japan is much larger than it would look like otherwise. Canada looks tiny. The US looks pretty similar to what it should be. Brazil looks pretty similar to what it should be. All right, then we have the isoline maps, and again, this is that we use lines to isolate specific features. So think about that when we isolate lines. And we use these to tell things like elevation. We use them looking at weather, all kinds of cool stuff. So you might use these if you are hiking or something. And again, we see that elevation through the lines. The closer they are together, the more steep an area is. And if you guys can hear a sound in the background, that's my dog. So sorry, she's weird. All right, so introduction to maps. And again, if I'm going too fast, pause the video. That's what's really cool about this is you don't have to wait. You don't have to catch up with me. You just have to pause me. So again, we're identifying types of maps. You should already have this on here, but now we're starting to get a little bit more deeply into this. We're on 1.1.2, types of spatial patterns on maps. So when we look at maps, we're looking at a few different things, and we need to know a few things about it. First off, we have absolute location and relative location. So absolute means it's something that is absolutely exactly there. And absolute location is exact. It's incredibly precise. It's an address. So the school is at 425 Mitchell Avenue. It's latitude and longitude. We could say that Rio de Janeiro is at 23 degrees south, 43 degrees west. That's an absolute location. Then we have a relative location. A relative is like, where is it in relation? Where is it relative to another place? The school is up the street from South Kitsap Helpline. It's up the street from Sinclair Inlet. Walmart is just behind Safeway. So relative to another place. Could say something like, it's next to my house. It's between Bethel and Lund. It's a whole bunch of different ways that we can look at a location relatively. And then we kind of get the same thing with absolute distance and relative distance. Absolute, again, exact and precise, but this time instead of looking at location, we're looking at distance. So we might look at miles or kilometers or feet. So we could say Oak Hills is 21.3 miles away from my house. That is an exact, absolute distance. Map scale is an absolute distance. So if you guys look over here, you can see that 1 to 62,500. That's a ratio or a fraction, a scale that's showing how big this map is as compared to what it represents on Earth. We could look at it on the graphic scale, that little line right there, or we could look at it on a verbal scale. So 1 inch equals 1 mile. And then we have relative distance. Relative, again, kind of related to other things, but a little bit different. So relative distance, we look at one thing in particular, and that's that spatial interaction. So this is the connections, the contacts, the movement, and the flow of things between places. So Amazon has drastically decreased relative distance. This is space-time compression. So we have huge spaces. Normally it would take huge amounts of time to get from point A to point B. But when we are able to compress that through some type of technology, then that changes the relative distance. So if I think about Tacoma is relatively far if I have to walk there, but it's relatively close if I have to drive there. Heck, if I had a helicopter, I could get to Tacoma really, really quickly. It's not far at all. That is relative distance. Technology, in this case a car or a helicopter, compresses that space and time. That's that space-time compression, and that's relative distance. So they're not exactly the same thing, but they're closely related. And basically it's saying that having these things, having technologies, having these interactions, they become relatively shorter or relatively longer. So Amazon has drastically decreased relative distance between consumers and products. So I can order anything and basically have it at my house within 2 days. If it's coming from Kent, I have it here the next day, right? So it's not far. And again, we're sticking with this absolute and relative for a minute. So absolute direction are exact, precise directions. It's absolutely that way. It's absolute or exact. This is our cardinal directions, north, south, east, or west, and I want you to be familiar with which way these are. So if we go to the school, is Sinclair Inlet north, south, east, or west of the school? And realistically, it's mostly north. A relative direction, this is relative relationships. You turn left at the Target, you take the second right, or the right at the second stop sign. You're looking at direction related or relative to something else. So in this case, I'm not saying you turn north, I'm saying you turn right. So we want to look at, again, we're looking at spatial patterns. Spatial just means space. So spatial patterns, how is something laid out in a space? First off, we're looking at clustering. When you have a whole bunch of things really close together, that's called clustering. It's related to density. So density would be the number of something in a defined area. I could have, let's look at this for a minute. This is density. I have 6 houses in this area. Now, I could take all of these houses and I could shove them up on this block right here. And they would still be the same density, but they'd be more clustered if I pushed them all up to together like that. And that we're going to look at that with the other terms we're looking at here. So dispersal or distribution says how far apart something is. So clustering, we think of it together. Dispersal or distributed, it's farther apart. And distribution is the way that something is spread out over an area. And then we have patterns and spatial associations. So this is an indication that two or more phenomena may be related, associated, or correlated with one another. If we have a whole lot of houses in one area, but we have a whole lot of stores right next to it, those are correlated. So that's a spatial association, it's a pattern association. You put grocery stores near houses because people need to go to the grocery store. So we have up here, we look at patterns. So all of these houses are in a row because they're all coming right out onto this street. Does that make sense? Hopefully it does. Still on our same objective, but now we're in 1.1.3. So I'm going to go back 1 second. All maps are selective in information. Map projections inevitably distort spatial relationships in shape, area, distance, and direction. Basically, maps are liars. All right. So map projections, and a map projection just means a map, really, because we are projecting the image of the Earth onto a flat, two-dimensional surface. That's a map projection. So they distort spatial relationships in shape, area, distance, or direction. They do, they have to, because we have... The Earth is a globe. It is round, and it basically is almost a perfect sphere. Not quite, but it's really close. To take that and to put that on a flat surface is really difficult, and it's impossible to do without making something really weird. So a map projection, the process of a cartographer's map maker, showing the curved surface of the Earth on a flat surface, the map. Realistically, all we're looking is projecting or showing the curved surface of the Earth, on a flat surface. And maps are selective in the way that they portray, in what they portray. So different projections are used for different purposes. Different types of maps, they're doing different stuff. So here, we're looking at one wonky little thing. We're looking at another one over here, okay? So we take this, we make it into this. This is called a Mercator projection. We're going to get into this stuff in a minute. And you can see, if you look closely, that it is a nice grid pattern. Nice straight lines. We are very used to seeing this map. We see it all the time. Very, very common. But if you look right along this line here, that's the equator, we can see nice, perfect little squares. Still looks pretty good right next to that. And then it starts getting a little long. This is because the map is lying. It's not really lying, but it's biased. It's literally, in this case, stretching the truth, okay? So the farther you get away from the equator, the more distorted this map gets. That means the stuff that's near the poles, so North Pole up here, South Pole down here, is going to get really stretched out, and it's going to look disproportionately large. So that's why we see things like Greenland looks, in this case, probably even bigger than Africa. Greenland is an island. Now, islands can be pretty big, but it's not that big. And it's certainly nowhere near the size of Africa, which is a huge continent. And Antarctica is not that big. It is not big at all, relatively speaking. Map projections are sad. And they are sad because they distort. And that sad is shape, area, distance, direction. They distort those four things. Alright, so I already told you this one is called a Mercator projection. It was created all the way back in 1569, and it was used for navigation. If you draw these lines on here and you say, okay, well, I need to go from Spain, right here, to the New World because it's 1569, all I have to do is draw a straight line from right here to wherever it is I want to go. And if I follow that on a compass and on my map, then I'm going to get there. As long as I keep following that line. This was perfect for navigation. It made it really easy to navigate because we have our longitude and latitudes, and essentially those are straight lines for our purposes. That's what these lines represent. So it has really great advantages in direction. We know north, we know south, we know east over here, and we know west. Really easy for direction. It keeps the shapes of the continents and countries great. These are exactly correct. We're using it for navigation, as I just told you, and it preserves the right angles of latitude and longitude, because even on the globe, those intersect at right angles, so that 90 degrees. However, as I was already telling you, it's got some disadvantages. So the areas near the poles are drastically distorted. This is distorting size, okay? And it is increasing the size of high latitude areas. So the farther, that's really saying the same thing, but the higher our latitudes, the more distorted the areas. They look huge. Next up, we have the Peters Equal Area Map. And this map is meant to give the correct proportion of land masses to each other. So the area of the land masses are accurate. We can see now, it looks real weird up here, real weird down here. Africa looks correctly huge. Greenland looks pretty darn small, relatively speaking. And Canada looks way smaller than it looks on every other map. Same thing with Russia. And if you now look, this is correct for the Antarctica. It looks like a flat little tiny thing because we're taking that round shape at the bottom and stretching it out. But it's tiny as compared to that map. So the area of the land masses are accurate, and it repositions many of the countries to their rightful size. That's really what it's saying. However, it's got some problems. These shapes are inaccurate near the poles, so while the size is great, this is not what it's shaped like. And it is vertically stretched near the equator, so it's kind of almost the opposite problem. It is kind of the opposite problem of the Mercator projection, where we see nice little squares down here, but in the middle we got big old rectangles. So now we're looking at Mercator and the Peters Equal Area Map overlaid, and we can see they get a little bit weird. Nothing quite lines up. The size of Africa takes up from the equal area map to the Mercator projection from the southern tip of Africa all the way up into the northern part of Europe. So in Mercator projection we look at, and I mentioned Africa and Greenland on purpose, so they're about the same size on a Mercator projection. In actuality, Greenland is tiny. It is nowhere near the size of Africa, so this is because that map is kind of lying to you. Then we have the Robinson projection. The Robinson projection is kind of like a cross between the other two. The shape is a little bit weird, but it's not quite as distorted as either of the other two. So there are advantages, no major distortions. It is meant to be a compromise. However, all aspects are a little bit distorted. So shape gets a little bit distorted, size gets a little bit distorted, direction gets a little bit distorted, because you see we go from basically squares here to they're now curvy down as we get farther away. Everything's a little bit wrong. And then we have other maps, because we can look at the world all kinds of ways. So we have a conic map. So if you set it upright, it is shaped like a cone. We have the azimuthal map. It's the sky right here. And we have the Fuller map. So every map distorts something. It's making it weird and hard to look at in some way. So this one's great because it's showing the correct shapes and sizes. But good luck finding your way anywhere on here. Kind of the same with some of these other ones. It just gets weird. Alright, so what's the point? Basically, what we want to know out of all of this is that all maps are selective. We are selecting to put in certain information. We are selecting to tell it in a certain way. We have purposes. Because we're looking at flat surfaces. We are distorting the Earth in some way, distorting the image of the Earth in some way. The best way to look at the world is on a globe, but globes are really hard to carry around, so it makes it a little bit inconvenient. But when we're looking at maps, I just want you to remember that there is some bias in there. It's lying to you a little bit in some ways. It's telling you what is or isn't important. It's telling you to look at a certain aspect, and it's ignoring and distorting something else. And it's really important that you remember that a map is not perfect. All right, that's it. So make sure you go back, rewatch anything that you missed. Make sure you got all your notes. Hopefully you paused, and be sure to take your short mini quiz when you're all finished with your notes. Okay, that's it for today. Bye.